All right, 2020 new problem review quiz number 2. This is a lab design question in which they want you to take the given lab equipment that they are requiring you to use and develop an experiment to figure out what gravity is. Now, this is very similar to an experiment that you did in honors physics with Mr. Miller, in which you had a ramp with an angle and a cart. In his experiment, there was no spring, and what he had you do was raise the ramp up through an angle theta and measure the length that the cart traveled through, and then use Vophista to figure out what gravity is, knowing that gravity is g sine theta, and then this guy is measured, and this guy is 2L over T, where this guy is also measured. So in Miller's experiment, you can do it this way to get the acceleration due to gravity. Now, what makes this problem a little bit different is that they're telling you that you have to use this spring. So letting it roll down the ramp is kind of cheating, and a couple of you did that. So what are we going to use and what are we going to measure here in this experiment? So this time, what we can do is we can let this cart sit here at rest, and the spring will hold it up the incline, kx, and we will have gravity point down the incline, so that'll be mg, and the part of the weight that points actually opposite the spring is, unlike some of you wrote, this guy has sine, mg sine theta. And then we also have the normal force that is not relevant to our situation here. So if we let this guy sit at rest, there are two variables that we can change on the left side here. We can either add mass to the cart, and that will stretch the spring more, or we can change the angle of the incline, and that will also stretch the spring more. So what equipment and what variables are we going to want? So to measure the mass of the cart, and that's supposed to be an E for scale. So to measure the mass of the cart, and if we put more masses in there, we're going to need a scale. Do they say that they want, let's see here, what are we measuring? The symbol used and the equipment. Okay, so mass, we're going to use M, and we're going to use a scale to measure that. And theta, we're going to need a protractor if we change the angle. And angle of incline. Now, since they gave us the angle, I'm guessing they don't want us to change the angle. They said it is set to an angle theta. And the last thing that we're going to need to measure is X, stretch of spring, and, oh, I've gone and changed the order here. The tool is going to be meter stick or ruler. Either one should be acceptable. So you're going to get 2 points for having all of these things. They need to be things that you actually can use to measure gravity, and you need to include symbol, thing that you're going to be measuring, tool that you're going to measure with, and what's the name of it. All right, part B. What is the procedure that we're going to use? Let's see, did I get everything? Almost. Let's bother. All right, there we go. Now, how are we going, what are we going to do? What are we going to measure? I think what they wanted was to, need to have the pen activated. One, measure length of spring. Two, add, let's see here, with ruler. They want you to write down how you're going to do the thing. The idea is to set up a recipe here for someone else who doesn't know what he's doing to replicate it. So tell them what to do and how are you going to do it. Add mass to cart, having measured with scale. Now, you can't assume that the masses that they give you are going to be stamped with, is this 50 grams, is this 100 grams, like we have in our lab, even though they said you have access, where is it? You have access to equipment commonly found in a high school physics laboratory. I don't know why some of you talk about photo gates, because our photo gates just don't work. We've got meter sticks, scales, and stopwatches. All right, so you measure the length with a ruler, you add the mass to the cart, repeat steps 1 and 2 for 5 different masses to minimize error. For, we're going to keep the angle constant. All right, what they want to see from you is we're going to measure something with a tool, we're going to change something and measure that guy with a tool. We're going to repeat it a bunch of times so that we can minimize error, and also this will let us make a graph. And we also need to keep something constant. Now, most of you did it the other way around between mass and angle. Most of you measured the length, good, and then you changed the angle. You need to make sure that you're going to measure it with a protractor if you're going to do that. So I'll write in blue here, Alt 2, we're going to change theta and measure with protractor. 3, repeat for 5 angles. A bunch of you said raise it between 0 and 90 degrees and measure the angles until it gets to 90 degrees. You didn't say repeat it for a specific number of angles. You need to do that. 4, you also need to indicate if we're changing theta, we're going to keep mass constant. That is the other thing that we could have changed, but in your case, you didn't change it, so you need to say that you're keeping it constant. All right, part B is 4 points for writing all of that. Part C, okay, now I'm going to have to get rid of my free body diagram here. Don't need that anymore. All right, part C. Which quantities can be graphed? Well, using my free body diagram from before, see, we had mg sine theta pointing down the incline, and we had kx pointing up the incline, and we measured x and m. And we chose m and then measured x. So what I would do is set these guys up so that my x variable is mass and my y variable is x, and then I would divide both sides by k. So I have x equals g sine theta over k times m. And this would give me y equals slope times x, where the mass is my x variable, the stretch of the spring is my y variable, and g sine theta over k is my slope. So what quantities that we measured can be graphed? So what I would say here is x-axis would be mass, and y-axis would be stretch of spring. All right, I'm going to have to clear these guys out so I can talk about D and E. Okay, I've cleared things out and rewritten C over here, condensed a bit. So for part D, what are we going to use to figure out what gravity is? So for my equation here, I have slope equals g sine theta over k. So gravity is going to be the known spring constant. Remember, they told us that we know what this is, times slope over sine theta. Now, if you decided to keep mass constant and you measured sine theta, your alternate option here gets you kx equals mg sine theta, but we kept m constant and we changed theta. So that means x equals mg over k, and then sine theta. You would have y is, your stretch turns into y, and sine theta turns into x, and then slope is mg over k, which means that g would equal k slope over m. Notice how all I've done is replace one thing that I kept constant with a different thing that I could keep constant. All right, part E, last part. They give us a graph here of position versus time and a wiggle, a bounce, and they say, okay, look at this. So it starts here, goes all the way down, comes back up to the same position. It's a little bit lower because we have friction to deal with naturally, but it goes through one full oscillation in 1 second. So we did cover this in class, and you did do a lab on it. So t equals 2 pi square root m over k. Notice that they say in the question, briefly describe how the students could use the graph to determine the mass of the new cart. Don't say you can just take the cart down and put it on the scale that you have to find out what the mass is. That's not the point. I know you can do that, and so do they. They want to know, can you figure out how to use the graph to figure out the mass of the cart? Now, the equation that we derived in class, or we were going to derive in class, so I had to do the screencast notes to do that, but it was part of the last topic. The period is 2 pi root m over k. The period we can get off of the graph. The period is from my starting position down and back to my starting position, which is 1 second. So we can get this guy from graph. K is known. So you can use simple harmonic motion equation for period of mass on a spring to solve for the mass, having gotten the period from the graph.